Yoshida has told you about what is classification. I will tell you something about clustering. Now to start, before going to clustering, I will just give you a kind of recapitulation of what classification is and then the difference between the two becomes. Just for that. So a kind of animation or whatever you call example of classification. A teacher is sitting over here. The teacher is trying to teach this student something. First job she does, she tells this student that this is a tomato. She tells this. She shows this. She tells it that this is a tomato. So this is what is in pedagogical terminology referred as training sample. Training sample. She is trying to train this boy that this is whatever may be the characteristics look and what it is. And the boy should learn this. So the boy learns and puts it in one hand. Now she shows this. This is something different. Now the same thing. She tries to teach the student. Something else. This was kind of red, this kind of green. Although shape is more or less. The teacher tells this boy, this is apple. This is a training sample again. The boy should learn. This was an example of tomato. This is an example of apple. So the boy divides it into two groups, two classes. And the process by which this guy is modifying his neural network is what is called training or learning. So one sample may not be sufficient. She brings some more. And this is also that learning. And puts it here. Brings one more. Again and one. So this process goes on with samples and samples and samples. This is the process, what is called training, what is called learning. Until now, the teacher is just stating this is this. She has not asked anything to the student. Trying to train him. The boy is supposed to learn, the boy is supposed to modify his neural network. So now this is over. So 6 months over, semester. Now comes the test. Okay? So next. Obviously she is going to ask what is this. If the boy has learned this apple, if not, then come up with something. So his answers in a positive way, and this is classified as this. Next sample. Answer is this. Tomato. Goes down. The boy passes. This is classification. Two classes, one class. Apple, one classes. Tomato. The boy was told that these are the characteristics or these are the features of a tomato. These are the characteristics and features of an apple. So these are the two groups of classes. So for classification, you need two phases. One is the training phase or learning phase. The second phase is called the testing phase. The last two questions which asked and answered, that is what was referred to as testing phase. So unknown samples or test samples, and the first few samples by which the teacher taught the boy was training patterns or training samples. So this process is called supervised learning, because there was a supervisor, there was a teacher who was supervising and telling him what is what. The whole process is supervised by the teacher. Now, life is a little different. Now, the boy has not been told anything. The boy is given a mixture of apples and tomatoes without any information, any previous knowledge. No teacher, nothing. Now somebody asks him, can you divide these into two groups? Just the question is, can you divide these into two groups? The boy does. Divides into two groups. There is no supervision, there is no training, there is no learning. So this is what is called clustering. This is what is called grouping. The point is, the patterns that came in one group are similar. The patterns that came into the other group are also similar. But the patterns between the groups are dissimilar. So if you are given a data set, in clustering, what you do is you divide the data set into a number of groups, so that the patterns or members in a group are similar, and the patterns or members which are in different groups are dissimilar. And the similarity, dissimilarity, they are different. That is the group control. If I ask somebody that divide the people over here, participants over here into two groups, how do you do it? Somebody will say, okay, male, female. Somebody will say, no, I will divide it into some other way. Say, based on language, based on height, based on whatever it is. So the point is, clustering does not have a unique solution. It can have multiple solutions depending on the type of similarity measure that you define. The similarity measure is defined beforehand, the result is zero. But if the similarity measure varies, the result varies. In classification, there is nothing like this. When the teacher taught the student the similarity measure, dissimilarity measure, features, everything was known. Number of groups were also. Let's say that you have a set of characters. Normally, this set of characters are having different colors. If you give a child and ask her to divide into groups, she will do it. She didn't have any previous knowledge, no knowledge. So that's grouping, that's clustering. That's so the basic difference between clustering and classification is, for classification you have training patterns, training samples. There is a supervisor who teaches you. It's like teaching in a class. First 3 months, 4 months you teach, you train the student, and then you give the test. That's a supervision, that's a supervised system, classification system. Clustering system is the other one. You ask somebody that, hey, I have this set of data, I want to divide this into a number of groups. How many homogeneous groups can I get? How many homogeneous groups can I get? That's exactly what clustering is. So this was what is the interaction with clustering. So in classification, how do you do? The goal of data classification, organize and categorize data into a number of classes. This is class, and that is cluster, different. Each class has a name, like the tomato is a class, apple is a class. Clusters do not have names, it's a group, it's a homogeneous group. You don't know what it is. It's a group, you know that it is a homogeneous group, but you cannot give any name. So normally what happens, the teacher teaches, so basically you try to create a model of the system. And given unknown pattern, then try to change the system. Like if you go back to your yesterday's discussion, or classifiers or model was the boundary bisector. We think of, I don't know, maybe Prof has told you minimum distance classifier. The classifier is the perpendicular bisector of the line joining the two. So that model is nothing but that line. In neural network, maybe the classification boundary. I think we will have some lecture on separate definition also. So they are also a kind of boundary. So that is the model. Clustering is unsupervised, where you really don't have anybody to guide you. It's self-learning, self-study. Quite naturally, clustering will be more difficult than classification. If there are teachers, if a teacher helps you to learn a subject, that is easy. If you have to learn of your own, that is difficult. So obviously, classification, clustering or unsupervised classification will be a harder problem than classification. There is no level, nothing is known about the data, but you are asked to do something. Clustering is sometimes referred to as unsupervised classification also. It's a name given. So normally whenever we say learning has two types, supervised and unsupervised. But practically unsupervised, there is no teacher, nobody helps you. It's kind of self-supervised. Given a data divided into a number of groups, and the groups are expected to be homogeneous with respect to certain characteristics. Like if my data looks like this. Obviously you can see that there is a group over here, there is a group over here, there is a group over here. This is a very trivial problem, very simple problem. I practically have three clusters. If somebody asks me to divide into two or three groups, like this. If somebody asks me to divide it into two groups, then that becomes four groups. In real life, the data is not like this, not so simple. Nice. So life is completely different. Now, formally, if you define, then clustering is nothing but grouping a data set such that in a cluster, at least one pattern is there. And the union of all clusters is equivalent to the total data set. That means you cannot have an empty cluster. And a single pattern cannot even belong to two clusters. A pattern has to belong to one cluster. So if you say I want to divide it into three groups, At least there should be a group where you have minimum one entry. So if you have total n patterns divided into n groups, our cluster can have a maximum of n minus 2 entries. Because other two has to go to the other two groups. That's a common application. So this is what is cluster grouping, dividing the data into number of. Now obviously you will be asking me, if I have some patterns, known pattern, then why should I go for clustering? Why cannot I do classification? Unfortunately, at least in real life, always you do not have training samples. Training patterns you cannot get always. Training patterns are very costly. Very costly. Normally choosing training patterns with 100% confidence, saying that yes, really this is an apple. Getting a teacher like this, getting a pattern like this is very difficult. So, generation of training patterns is difficult. You don't always have it. There are plenty of problems where you need to do, you are compelled to do. So you have to do it. So you need to learn clustering techniques. Now, for doing clustering, the basic philosophy is this. Intra-class distances are minimized. So these distances inside this pair, all possible pair, the total distance is minimized. That means this is a compact, homogeneous group. Trains who have very common characteristics, they it's a cluster, it's a group. If your characteristic doesn't match with your friend's characteristics, sometimes there will be separation. No chance. For doing clustering, the basic thing that you do is you are trying to maximize the separation between the groups, minimize the separation between the patterns within a group. It's a basic philosophy. How we want to do is, I should not say that maximize the distance. Once again, I should say, use the concept of similarity, because similarity varies from. Like, if I have two data sets, like this, and if I apply this principle, it's not going to work. The distance measure is not going to work. What is going to work here is the angle that it makes with the x-axis. So that is my similarity measure for this particular case. Most important thing in clustering is defining this similarity measure rather than doing the clustering. Once this is clear, if you know the data distribution, because you have n-dimensional data, you cannot see it. It's two-dimensional, simple. I can see it, I can decide. Even if you say 100 dimensional, you cannot see how does this distribution. So you cannot define the similarity. So rather than designing some clustering algorithm, what is more important is decide upon what sort of similarity measure. So, as in pattern classification, all these things come into picture for clustering also. How many features you want to use? What are the characteristics you want to use? Like an apple, how do you want to represent an apple? Color can be one feature, weight can be another feature. Because we can see, the computer cannot see. For computer, everything is in numeric type. real number. So how do you represent that? Say we take 2 features, 3 features, 10 features, and whatever it is. Those feature values. Which features are important, which features are not important. So the proximity measure or similarity measure and associated clustering criteria, how do I optimize? What do I optimize? These are more important issues. Then obviously the question will come, I have designed an algorithm which is giving me a set of clusters. Somebody else has designed another algorithm which is giving another set of clusters. So which of these two is better? So you need to define something what is called the cluster validity measure, which will tell you how good are the generated clusters. These are all associated issues. You cannot solve this in one day. And obviously final is this, how to interpret this to be used for math. Say for example, nowadays if you think of 10 years back, if you go for a shopping, if you want to go to bazaar or whatever you say, and you want to buy items like bread, butter, banana, milk and other things, life will have to be difficult. You go to one place, buy milk, another place banana, another place bread and other things. Nowadays, in supermarkets or shopping malls, whatever you call, you will see that all these items are placed in one location. They have plastered this. They have put this. That was the interpretation. The interpretation was all of these are breakfast items. So with respect to that particular feature, these are similar. Physically, bread does not have any similarity with butter or banana or milk. But if I consider with respect to when do I use it, for what purpose do I use it, that is my feature, that is my criteria. Then that's good. That criteria was optimized. And nowadays we go to supermarket, you see that all these items are in one location. So they are similar with respect to that particular thing one, not with respect to any other. Physically they are completely different. You see that all fruits are placed in one location. All electronic items are there in similar place. So these are grouping, these are clustering. By clustering, people have, this maximum improvement in supermarket is due to the effect of clustering. If you cluster the buying pattern of customers, you will see that people who pay in credit card, they usually spend more. Usually they spend more. People who are paying in cash, they buy less costly products. So one group is for Big Bazaar, another group is for Spencer's. So Big Bazaar is cash group. It's not good bad, it's a group. If you think of age-wise, you consider people who are above 60, they always buy cheap products. The person who is in between 20 to 30 will buy costly products. So depending on requirement, depending on criteria, the clusters are there. Clusters are different. And clustering is being used for all these purposes. Young people go shopping in the evening, old people go shopping in the morning. It's found out by trusted people. It's not myself. From today you start noticing this. All old people go if you really want to see application, thousands of fields are there where this grouping is being approached. Fraud detection is a very standard example of use of cluster. Cyber crime detection. Basic philosophy is, if you cluster the data, the person who is doing the crime, he will be outside the cluster. He is an outlier. He doesn't form any pattern. You have your own way of handling your user. Now you know what time you go to office and when you open your account. Statistically, it's more or less correct. The person who is going to do the crime, he will not open that account around that time. He will open an odd hour. So if you cluster the data, you will see that this is an example very outside. That's what is called outlier. Outlier detection is again an important issue in clustering. Because that could be noise also. The difference between noise and outlier is very important. Very popular in intrusion detection or cyber crime detection or whatever. The naming system, species naming system in biology, like we are Homo sapiens, it's nothing but clustering, it's nothing but. If you go to, I don't know how many of you go to library nowadays. Nowadays students do not go to library, but if you really go to library, you see that every book has a number. You call it accession number or call number or whatever it is. These numbers are not random numbers. These numbers have some sequence. For example, say all books which are from mathematics department will have a unique number at the beginning. It's 631 point something. So this 631 is the code for mathematics. Maybe for computer science the code is 653. So the clustering is done. The whole books in the library divided into say, let's say 3 groups: mathematics, computer science, other science, natural science. Then in mathematics, maybe calculus, real analysis, matrix analysis. So groups. So this is what is called hierarchical clustering. So finally, this way, you go down, you will see that each book has a unique number. You go up, you can group them. So similar way, this biological species number is done. So nowadays everywhere in the world you see applications of clustering. So this is all about clustering. A good clustering method will produce high quality clusters. And high quality means intra-class similarity is very high. Inter-class similarity is very high. Two groups, two elements which are very similar will be inside a single group. Two elements which are not similar will be included. And obviously the quality will depend upon how you define these measures. Lots of research are going on all these issues. Now depending on all these criteria, everybody is coming up with a new cluster here. Yes, I want to do and since there is no unique answer, all of them are correct. All answers. So nowadays maybe you will get around 1,000 clustering techniques, 1,000 clustering algorithms. These algorithms can be clustered into these 5 groups, can be divided into these 5 groups, or can be classified into these 5 groups. One is partitioning algorithm, one is hierarchical algorithm, one is density based, grid based, and model based. These are the 5 major types of clustering algorithms available nowadays. These are types, these are not algorithms. It's a group, it's a class, it's a class level. What partitioning. It's a cluster hierarchy. So whatever the set of number of algorithms be here, they will have a common property. First partition the set into number of groups and then repartition this. Do this iteratively until you find a compact way. That's why the name partition. Hierarchical is this library system. In hierarchy we find the clusters. So similarly, density based is one way. When there is a high density, assume that we get a cluster. Then grid based is you divide the whole data into a number of grids, then either marginal grids or split the grids. Model based is you generate a model of the cluster. Like in classification, you are generating a model. So similarly, you try to generate a model and use that model for cluster. Normally, these three are very popular. Nowadays, because of this big data concept or data mining concept, these things are also coming up. Like even density based also came up to this data mining business. And these two are very classical standard pattern recognition ways. So maybe in due course we'll talk about a couple of these ideas. So first is clustering based partitioning based. How do you do the clustering? So partitioning philosophy is you divide the whole data set randomly into k groups. When you want to divide the data into k clusters, this k, how to determine this k is again a big issue. Nobody knows. Normally you just apply. So this is the biggest bottleneck of clustering. There's no solution yet. People are doing some research. They are suggesting, okay, I can have an estimate of k like this. But still now no unique answer. So first you divide the whole data into k groups, then find out the similarity between the elements in each group. If you see that they are not properly grouped, then you repartition this, regroup the business. So if I want to divide these people and then all into two, randomly I divide. Those people who are sitting on this side and people are. Then with respect to certain characteristics, I say no, they are not similar, then addition. So this reshuffling is repartition. This I continue until unless I see that yes, elements on this side and elements on the other side are really homogeneous. So that is partition and repartition. That's grouping. And the most popular among these partitioning based techniques is what is known as k-means cluster. Now this we will study in little detail. So if we understand this, then the partitioning concept should be clear. K-means cluster. A modified version of k-means is what is called k-meter or partitioning error, and is very popular nowadays. This came in the advent of data mining. This is classical k-means dividing into k-groups, which is an example of partitioning cluster. Now let's see how does k-means algorithm work. This you should understand very clearly. All other things are dependent on this. It's the simplest possible clustering algorithm that has been discovered. Very cheap, very simple, but may not be always. So the idea is very simple. Somebody has given you the key. Somebody has told you, yes, the data set should be divided into k groups. Let's say I have 1000 objects, 1000 patterns, 1000 elements, and k is equal to just 5. So then my thing, I want to divide that 1000 data into 5 groups. And these groups should be similar, should be compact. Let us assume that this similarity or compactness we are measuring with respect to Euclidean distance. Just one criteria. It's just an assumption. It's not that always it has to be Euclidean. It can be any similar, like for that sort of data, I have to use the angle measure. But other things remain same. It doesn't change. The criteria just changes. So what you do is, you randomly pick up k points or 5 points from those 1000 points. I have 1000 data. I pick up just 5 of them, k equal to 5. 5 of them randomly, without any bias, anything. Use the random number generator. Let the first data be data number 759. So just 5 data I want to divide. Now I am left with 995 data points. Take all of them one by one. Take one data out of this 995. Find out the similarity of this data point from those initially picked up 5 points. Initially I have picked up 5 points. That is my k. Now I have picked up one more point, 6 points. Find out the similarity of this 6 point from all those 5 picked up points. Whichever of these 5 points is most similar with this 6th one, I say that the 6th one belongs to that particular group. So let's say that the 6th one is most similar with number 5. So now 5 and 6 forms a group. And 1 is a group, 2 is a group, 3 is a group. So now I take one more point and do the same thing. Find out the similarity of this point from this cluster and other 4 points. Whichever is the most similar, I assign this. So this way I do, this way I continue for all remaining 995 points. So now I have 5 groups, and each group will have a set of points. How many points I do not know. But that depends upon what was the similarity measure, what was the initial pickup points. Okay, so let's say that first group has 100 points, second group has 200, third group has again 1, and so on. Now you find out the mean value, arithmetic mean value, average value of the points in each cluster. You have 100 points in first cluster, to find out the mean of those 100 points. You have 200 points in the second cluster, find out the mean of those 100 points. So this way you will get 5 mean values, 5 average values. These average values are the new k points or new c points, new mean points. And this is why the name k means. The means are being used here as the representative. So now we have k means, k values. This is all your 1000 points. We have only these k mean values. These may be points, may not be points. Maybe hypothetical values also. Because that's an average. So now you release 1000 points. Then again you pick up those 1000 points one by one. Find out the similarity from these means and assign to the process. You do it for all 1000 points. The second iteration. At the end of this, you refine the mean value, recompute the mean value. So you again get k mean points. So this mean is expected to be different from the previous mean. Again release the 1000 points. do the same thing. So this you continue until you see that all these k mean values are remaining identical. If you see that these k means are not changing at all, that shows this repartitioning is not occurring anymore. Whatever points came into cluster number 1 in the first iteration is coming in the next iteration also. So you stop. And whatever points are there in cluster number 1, that is your first loop. Whatever points are there in cluster number 2, that's the second loop, and so on and so forth. So with a set of mean values, set of seed points, you are partitioning the data set. The data mean value is changed, you are repartitioning it, regrouping it. So that's why it is called a partition based. Iterative method, you are getting low basically. Iteration after iteration. So if you read the slide point by point, randomly select k objects as initial seeds, random points. These are randomly picked up, doesn't matter. Assign each object to the cluster with the nearest seed point. This is a maximum similarity. Compute seed points after all the points are assigned to the cluster. And go back. So this looping you continue. 2, 3, 4, 2, 3, 4 you continue until you have come to a stable state. Stable state means you are not changing your data points. No redistribution, no reassignment. Maybe it's animated, I think. So like this, you have picked up these 3 points randomly. It's divided into three groups, 3 clusters, k equal to 3. 1, 2, 3. These are randomly picked up points, initial seed points. Considering the distance, these points come under this more or less red mark. Then green mark comes in one group and blue comes in. So now you compute the mean of this, the mean changes to this position, average value in this. So this point is shifted here, this is shifted here, this is shifted here. Second iteration. So now assuming these to be the means, you redistribute and find out the mean like this. So this way if you go on iterating, you will see that finally you are taking it like this, and like this. Practically, this point is a kind of outlier. It's kind of intrusion. This is the suspect.
Sir, I have a question, sir. Suppose we select k points and k points are near to each other.
K points are
Near to each other. It means 2 points are near to each other. That time it is a very big problem to classify.
Before answering you, let me point out the mistake. I don't know the first when I started the lecturing, were there in the hall or not. I told you this is not classification.
Yeah,
It is not classifying. So first correct this. This is why I spent maybe another 15-20 minutes in the beginning, because this is a very standard thing people do. And that's why my learning, I modified my network to correct this, but finally I failed. Now I tell you what is the problem.
In clustering, sir, when we choose 2 points and when I select
It
3
will not
points
be a
randomly
problem.
and 2 points are near to each other.
It will not be a problem. I should not say it will not be a problem. Obviously it will be a problem. The problem will be it will take more time, more iterations to regroup. Finally it will do that. Whatever may be your random points, initial picker, it will do the grouping. The only thing is if the pick the points, if you initially pick up these 3 points here, 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 then you are the luckiest person in the world. In 1 or 2 iterations, it will be over. And if you are unlucky and pick up all 3 points from here, it will take more time. Finally, it will come down to a clustering like this. It will just take more time. So that is the problem. If you consider that to be a problem, yes, that is the problem. So that's why what people try to do is, if you have some knowledge, some idea about the data, then these points you pick up and assign. If you have the idea about this. Okay? If you have some knowledge, you pick up these points and say that these are my initial points. Your time will be set, money will be set. That's what we normally do. If I know that you do very well this transport assignment, then I will pick up you as a volunteer for that job only, rather than assigning to the food distribution. So that's the stage. If you have previous knowledge, you use this. If you do not have, start with random values, it will what? Much required. It sounds about learning. The learning time is more in that case.
Or we need to take random value again, try to calculate
You
random.
can do that also. But after you do not know, how do you say that the point that I have picked up, they are close? How do you say that?
According to the value.
Hmm?
According to the value of the point.
It's the same thing.
How?
Distance, calculate the distance.
Calculate the distance, okay? And then
If distance are very low, very low. Distance are very less, then we can say
what
that
is this less? How do you define less? You do not know whether within that there are some more points. Let's say you will say that if the distance is less than 10, I will say they are close.
yes.
But maybe within this 10 only you have all points. Then you are in a group. This 10 or whatever you are defining is relative. You do not know. Maybe that is the farthest point available. So maybe this is the same thing in a little bit animated fashion. So no point in doing this. Its mean value is just changing another thing. So finally you are getting two groups. K-means is the simplest. It's very easy to understand. But it really doesn't work for us. So there are many advantages and disadvantages of them. So the next algorithm is variance of them. Many variants, many modifications of these sorts of description. Many, not one, two,
Sir,
three.
sir, previous slide. Sir, second last one, unable to handle noisy data and outliers. The difference.
Outlier is the point which is far away from a group. Let us say,
Sir, if we can use darker marker.
let's say I am given this. Can you see now? So why don't you come here? Come here, come here. There is a chair. No, I think angle problem. There is a chair. Just come on.
Okay, thank you.
Light travels in a straight line. Let's say the data that you are given looks like this. This is how the data looks like. This is you are given. You have no control on this. And say this is, I mentioned the 2 dimensions so that I can see. So now, practically, this is a group. This is what is called outlier. This point is basically a noisy. Let's say supermarket data, if you see that maybe date of birth of a person is written as 1823. Is this a valid data? Date of birth of a person, of a customer. Valid active customer. So this is kind of point like this. This is what is called outlier or noise. So this sort of things K-means cannot handle, because K-means, what K-means does is it will try to put this point in one of these two groups. So once it puts in this group, the whole mean changes here.
So noisy data outliers or outliers.
Both are noise. Outliers are those noisy points which are useful for some purposes. Like the cyber crime I am talking about, those points are outliers, and those points are noisy points obviously. But that is being used to detect the crime. So they are outliers. Is the 12th man sitting outside the bench. They are outliers. Not in that team, but useful. A noise is somebody who is sitting somewhere else.
Let's say I access my very difficult.
There's no definition. Way of defining it clearly. What is the distance?
Let's say I go to work at 9 a.m. in my office, and usually at 10 a.m. I check my bank. But let's say in the evening I remember that I forgot something, so at 1 a.m. in the night I check my bank. So that is actually an outlier, but it is a valid transaction because I am doing it. Somebody else may also be doing it. You need to differentiate between it, right? Very difficult time.
That is a suspect. That's not a confirmed
So
test.
that outlier would, when you analyze the data, that outlier.
These outliers will be analyzed again with
Yeah.
with some more information to give a validity like this.
Noisy data you can always do away actually, but outlier is something which is valid.
No, noise data also you cannot do away.
You want to do away.
We want to do it. Everything is noise. Outlier is also noise. With respect to my purpose, outlier is noise. But that may be useful for somebody else. If that is useful for somebody else for some purpose, that is considered as outlier. It's not at all useful for anybody. It's considered as noise. Practically an unwanted thing.
There should be some anomalous features.
Yeah, anomalous. This is anomalous. But saying that is really a noise or saying that it's really an outlier is
Sir,
yes.
in last slide, sir, how the local optimum value is strength of this algorithm? Why not global optimum value is more good?
I will answer this.
Sir, after applying K-means algorithm, whenever we have decided the number of the K, after 10,000 or 5,000 iteration, it may be possible one of them cluster is not occupied. One of them is not occupied by any instances. Suppose we have decided K equals 3, and I have 100 examples. I am grouping these 100 examples into the 3 clusters, and I have applied 10,000 iterations for the compactness. After 10,000 iterations, it may be possible that only 2 clusters are occupied, one of them is not occupied.
No. Cannot be. Cannot be. It cannot be.
Empty cluster.
No. Initially your K is 3. Initially your K is 3. So the first point is inside that only.
Yes.
So how can that be vacant?
No, after 10,000 iterations.
Yeah.
One point is there, minimum of that particular cluster will be the point itself, no? So how it can be empty? It cannot be empty in any circumstance.
Hold on. Let him be honest. How many points you have? 100 points. First 3 points you have picked up. So 3 clusters. Now you have 97 points. 97 goes into 2. So the means of these 2 changes. How about the mean of this? Same, it doesn't change. So this pattern will always remain inside this cluster. There is no new forest. So empty, it cannot be. This point cannot belong to any other cluster.
We are updating the mean.
Updating the mean. So after first iteration, what is the mean of the first cluster?
Something in between and so 940.
No, sir. It's not something. It's the same point only because nothing has come out.
Okay.
It's only having only single point, please stop.
Okay. So,
Mean is the
but
number.
after second iteration, that sample has 2 points after second iteration. After second iteration, the mean has been changed. Then at that case, what will happen?
One of them will be the closest to this.
Suppose we have
One of
started,
these 2 points
yes, sir.
will be the closest.
Suppose we have started 3 initial points. We have started 3 initial points, and I have classified 97 points into these 80 points. And the 97 points are grouped into 2 clusters, and 1 point is empty because it is already assigned 1 point. Okay. Then after
Empty means 0.
not empty 0. It
It's
is
a
a
single
1
point.
point.
That's what is called single point.
It is a 1 point. And I have applied this equation again second time. Then the only cluster which have only 1 point is taking 3 points after second iteration. And the mean has been changed. Mean has been changed.
Maybe
mean has been
maybe
changed.
we'll talk on this issue after the lecture because I need to finish something. I will be here. The whole day. Okay, so it's here. So considering the advantages and disadvantages of K-means, some modifications are suggested. The simplest possible modification to take care of the problem that somebody was pointing out there, to take care of the problem of outliers or noise or whatever you call, is referred to as K-Medoid's algorithm. K-Medoid's algorithm. Rather than K means, they call it K-Medoid. What is a Medoid? Let's say these are the 5 points, 6 points assigned to this cluster. And average is this. This average is not a point from the group. It's not one of the samples present, one of the data points. It's not. It's something extra. So this is the mean. The point from this set, which is nearest to this, is called the midpoint. A point, existing point of the data set nearest to this mean is called a midpoint. In K-Medoid's algorithm, what you do is you compute the mean, find out the nearest midpoint, and assume that this is your next seed. That's the only change. All other things are identical. First compute the mean. Don't take the mean. Find out the nearest point existing in the set. And that point is considered to be the set point of the next repartitioning business. Now this is a very simple modification, but it has a very big effect. Performance improves a lot. Because let's say for this class, the mean is here. But the midpoint is not here. The midpoint is somewhere here. So the cluster is biased towards this. So the total partitioning and repartitioning will be better. That's an advantage. The mean is somewhere, but once you shift this point towards here, so this point becomes closest to this. In the previous case, it should have been somewhere here. So for some data distribution, not all, manage. For some data distributions where this arithmetic mean problem is there, this problem of standard problem in arithmetic mean. If you want to compute the average salary of us, somebody who earns in crores and somebody who earns in thousands, the average becomes very high. That is the effect. So that is the problem of mean. So instead of taking the mean, if you take the nearest existing point, then that will be in thousands. So detection of this point is easy. So that's why sometimes in even statistics, what people do is they exclude the outliers, what they call it boundary points. First remove it. They are not points. If you are in an interview board, the same thing happens. 10 people are there giving marks. Some teacher has a scale of 99 to 100, another teacher has a scale of 50 to 60. So both are outliers. Remove them. And keep the outliers. The same thing is like this will reduce the effect of outliers and noise in classification. I am not claiming that this will nullify the effect. This will reduce the effect. That's the advantage. Disadvantage is it's very costly. Disadvantage is it's very costly because finding out the nearest existing point of the set from the mean is a very costly affair. Because you have to find out the distance of all possible points inside the set. In the picture it will look very nice. Yes, sir, this is the closest, this is the nearest. But if you want to write a program, that becomes difficult. You have to find out the distance of all points. You can sort it and take the nearest one. This is very costly. So this way, plenty of modifications are suggested, plenty of modifications. Each of them has its advantages, disadvantages and all these things. Which has an animation again. Now, this is my data set. So these are the two initial data points. Maybe these are the distributions. Computed mean and then the nearest midpoint like this. So this way it goes and only effect of noise or outlier is more. So these are the two examples of partitioning based clustering. Next is hierarchical clustering.
Like in midwife, I know it median and one dimension, high dimension is different. So like we are considering this point, data point, which is nearest to this calculated mean. Instead of taking a single value, which is nearest to this, I think we will take more than one.
You can do anything. You can do anything, you will get another clustering algorithm.
So like we are finding here.
That's why we have thousands of algorithms. People are suggesting this modification, this modification, this, that, and for some data they are showing a series working. That's what is research.
should be significant because 1 is not significant. If it is sufficient number, the data points are very large.
That's a big question. Significant. If you say significant, then you have to go for t-test, t-test and all these things. Just saying that it is significant, it's not significant, is not going to matter.
In terms of like just picking a point, a single point, I think in a large data set, like we are calculating.
No, okay, you don't want single data set. How many want? Single data point you don't know. How many want?
If we know the variation, like if we are having a distance, we know the variation also between the two.
Variation of what?
Variation between the two data points.
Distance between them.
Yeah.
I know.
So I think if we calculate some threshold,
How this threshold comes? Where? Who tells you this threshold?
like if suppose the mean having a very
Everywhere there will be a suppose. So
Definitely.
it will not work. That's the problem. Somebody else taken one, you are saying no, I will take 2, I will say 3. She will say no, 4. This goes up. That's how the number of clustering techniques are coming. But these are very minor things. It doesn't count. That did that tell you about KNN? KNN statement. So K, what is the value of K? That is the same thing here. These are not important issues. Important issue is the jump is there. Mean is a fictitious point. You take the nearest midpoint, then the result is going to differ a lot. As I given in the example of the salary. If you consider a company, the manager takes maybe 2 lakh rupees a month, whereas the laborers get 10,000. So what is the average salary? If you consider the manager's salary, then 1 is to 20. He needs 20. But if you remove him, then if you give an exact reflection of that salary. So that is the difference between mean and true. That's a big jump. But if you take this 1 or 2 or 3, it's not going to matter much. It will matter.
So just in previous slide.
Previous slide.
Term is not suitable for very large data, large scale data. That means it is only for efficiency consideration or
Efficiency.
if you use the cluster of processor, it will be
Efficiency. Just time. Not, I mean, on in current recognition terminals, we should call this not scale error. Okay. Next, we will switch to something completely different. What is called hierarchical clustering. The domain is not changed, not for partitioning. Ordered based. This is that book classification problem of library. Let's say I have 5 points. These are my points. Point number 1, 2, 3, 4, 5. So 5 points I have. In the first step, what I do is I find out the distance between all possible pairs. And I merge the closest pair. Initially I say there are 5 points, means there are 5 clusters. That's level 1. Level 2, I merge 2. Which 2 I merge? The nearest. Most similar points. So now I have 4. These 2 in one group and the remaining 3 as one. Next again I have 4. So I have 4 C2 possible distances. I complete all of them. And again I merge the nearest. So next level I have 3 clusters. Next level I will have 2 clusters and then I have 1 cluster. Advantage or disadvantage is this is the whole set single cluster. At this level you have 2. Some other level you have something else. So if you are at a particular level, you know how many clusters are there. But you do not know where to stop. What is the optimum cluster? How can I say how many clusters are there? That's not certain. somebody says, okay, at this level, how many books are there, how many clusters are there, you can answer. One book is one cluster. Then maybe all books in algorithm is one cluster in the next level. And all books in computer science, one cluster, next level. This is what is called hierarchical clustering. So this is the forward direction or agglomerative. This is what is called agglomerative clustering. The combining. The same thing you can do in another way, reverse way, divisives. I am initially assuming there is one group, then dividing it, then dividing into 3, then dividing into 4. So either bottom to top or top to bottom. Both ways you can do that clustering. Effectively it will be same. So if it is in the top and then you are coming down to bottom, this is called divisive, you are dividing it. Another way, it's called agglomerative. This has very limited applications, I would say, like species identification and library system analysis. The next popular clustering is what is called density-based clustering. So these are big shifts. They are not minor things like taking k equal to 1, 2, 3, or rather than taking the mid-order, I will take another point. It's not like that. The shift is maximum. Just look at this example first, then I will come to the theory. So here the basic assumption is I will pick up a set of points, or I will say that I will take a small circle of some radius epsilon. If I have at least 10 points, let's say, then I say it's very compact. Let's say it's very dense. Like equivalent to say one village, you will see that many houses are in one place. But between villages, there are no houses. So this is a dense place, that's a dense place. If you village, what will happen if you take a radius of say 0.5 kilometer, half kilometer, you will say maybe 100 houses are there. But in between two villages, you will say there are no houses. So that is the dense group. This philosophy is being used to find out clusters or groups. If the data distribution is like this, then obviously this is a very dense region. This is a dense region. So this is a group, this is a group. This is not a group. So this is detected as an outlier. This is detected as a noise. This is the paradigm shift. If you use this concept, you get groups, clusters, association with outliers or noises. In K-means or K-medoid or hierarchical, these were not treated as noise signals. These were assigned to some clusters. But in density based, you can detect the noise signals also. So here the basic philosophy is, first what you do is, you pick up a point randomly. Then take a small volume around that. And what should be the radius of the volume is user sunlight. And if a minimum number of points are there within that volume, that minimum number is again user sunlight. So two parameters are supplied, that epsilon and the minimum number of points. Then you say this is a compact region, this is a dense region. So this is my initial cluster. This cluster you go and expand. This is the compact one. I see that in very close proximity of this there are other points. So they also come under this group. So this way you go on expanding your group. Initially the seed, you go on expanding. Finally you will get a group beyond which there are some vacant regions, not much dense points. So that's what I am referring as the distance between two houses, between two villages, between two cities, where you have really a big highway, long highway. So once you get one group, that's one cluster. Next, you go to another region, you get another cluster. So advantage of this, initially you don't need to know how many groups you are looking for. Like in K means, you know that you are looking for K groups, K clusters. Here you do not know. That's an advantage. Disadvantage is you have to define your epsilon radius and the minimum number of points. But if you can choose this radius and minimum number of points properly, you don't need to find out, you don't need to know the number of clusters a priori, and your outliers and noisy points will be automatically detected. These 1 or 2 points will never be grouped as a cluster. They will be treated as noisy points. Because this is not dense, there is no density, very less dense. So density based is again a paradigm shift. It's very popular. One of the very popular things is what is called DB scan, density based scan. Now it's most popularly used because it automatically tells you the outlier. But that epsilon and mean point less. So maybe I will stop here because the time allocated is something like this. Somebody was asking, have you got your answer? No? So then again you tell me the question. You are not listening. You are questioning with your friend. That's why you did not get the answer. I think the next class you should be separated.
जो स्लाइड था उसमें के मीन लोकल ऑप्टिमम वैल्यू पे रहता है वो स्ट्रेंथ की जो स्लाइड था
The advantages of K means here is referring to that the local optima. If you go to the K means advantages of K means. This one, that's the second one. Often terminates as a local optima. Second.
So why do you consider it to be strength? Is that the point? If you want to find out the global maximum, so these points will not be properly classified. These noisy points or outlier points will not be properly grouped. But if you want a local, then these points will be treated as a separate cluster, separate groups. So that's what is considered as an advantage.
Sir, in density-based clustering algorithm, what is the shape of the clusters? Like in this case, we are already in the circle.
It evolves. It's irregular shape. And that is the advantage. Even if you can detect irregular shaped clusters by density based, which you cannot get by chemicals. Because in real life, you have irregular shapes. That's considered as an advantage. Okay? Anything else? Yeah. I could not cover all this. There are plenty of measures which are called cluster validity measures. Plenty. Many cluster validity measures are there, like Davis Boolean index, and Jacob coefficient, many, not one. Plenty of things are there. If your validity, this validity indices gives you a measure of how compact the groups are and how much dissimilar the groups are. So if the validity indices are high, you say that you are going to say better.
Actually, it's the quality of cluster.
Yeah.
So I'm saying about correctness.
Quality and correctness is the same. Yeah. So if you find out the validity measures, whichever is giving you higher validity value, that is it. Correctness. What is correctness? You are given a data. You do not know the levels. So there is nothing like correctness. Nobody knows whether this is an apple or orange or what. Simply. So only you can define some measure, quantitative values, So then those are referred to as valid deviations. Correct means there has to have a judge who knows what is the level, what is this. For supervised learning, there is nothing like that. And that's the fundamental difference between classification and clustering. In clustering, you never have this level, so you cannot find out the level. I don't know whether you are talking about some papers. In some papers, you will say that this is giving us this percent correctness and whatever it is. If that is the case, then they are assuming some data. They are assuming some data where class levels are available. Where class levels are available. So they are just to show that my algorithm is better than the other. They are using that. But practically, you will never have a data with class levels. If you have that, then go for classification. Then go for clustering. That's one way of cheating. To show that yes, I am giving 99% accuracy. This algorithm is not. That really doesn't make sense.
Sir, one more. These distance measures are always preferred to have some geometric shapes. So when you say that we can detect any random shape, that means we are choosing that this random.
Give me scan.
Like that. So whatever the measures we are choosing, that will tend to measure that shape.
Let's say this is my initial group. This is my initial group. Now there are points I expand in this direction. Density, 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 density. Well, yeah.
Start the median distance, and it seems that with the parameter median distance, results are not coming good. So you go with the other distance. So is there any knowledge tried that give you the data that this distance is going to work best in this case?
If you can see the data, yes it is. Like this data, you use angle measure. For some data, you use something what is called azimuth measure. But in real life, the data is in high dimension. So you cannot see it. So nobody can comment on that. Only trial and error or the best possible suggestion is to do a kind of thing what people nowadays refer to as subspace cluster. So the main philosophy is try to project the data from a high dimension to a lower dimension so that you can have a visual representation. And then take some cube to define the measure. These are cubes. This does not guarantee. But in majority of the cases, this will be. Plenty of techniques are there. So you have to reduce the number of dimensions.
Or dimension reduction.
Any dimensional reduction technique. You have to reduce the dimension. Yes, sir. Tell me.
Sir, sometime during the discussion, you have a passing remark on p-test and t-test. Can you elaborate a little on that?
No, I don't think I have time for that. Maybe if you are interested, I can talk to you outside this. T-test is a very standard test in statistics, which is called students t-test. Very, very popular nowadays. The point is, whenever we write research papers, what we say that I have got 99% accuracy, your algorithm is 98%, 98%, so I am better than you. This is this 1%. This 1% may not always be significant. That's the problem. How do you measure that this 1% is significant or not? For some cases, some data distribution, maybe 1% is very high. For some data, maybe you need 5%, 8%. This jumps. So that is being determined by something what is called t-test. That's very popular, standard things. Like Gold you cannot measure in kilograms, you measure in grams. But iron you measure in kilograms. So you are comparing irons and saying, okay, this is 1 gram extra, so I am giving you something better. It doesn't make sense. It's not significant. So this significance has to be measured. And for measuring that, you use something that's called statistics. Okay, so let us close down now.
So no further questions. Let us approve the Ghosh.